Construction and working of shortwave diathermy. So shortwave diathermy consists of two circuits, that is mission circuit and resonator circuit or patient circuit. So first, coming to the patient circuit consists of an inductance and an condenser. So the inductance is EF, this is the inductance coil, and a condenser which is known as HK. This is the patient circuit or the resonator circuit. Close to the patient circuit, there is another coil, oscillated coil known as CD. This is the inductance of the oscillator coil, and it has a condenser called XY. So this is the patient terminal. So remember, this is the resonator circuit and this is the oscillator circuit. So the resonator circuit consists of an inductor coil EF and a condenser HK. This resonator coil or patient circuit. Resonator circuit or patient circuit consists of an inductor coil EF and a condenser HK. Close to the inductor coil, there is an oscillating coil CD, which is the inductor with a condenser XY. This is the oscillator coil. This is the resonator coil. So this is this is the patient circuit. So coming to the main mission circuit, it consists of two transformers. Both are connected to an AC current. It is a step down transformer and this is a step up transformer. So the step down transformer's secondary coil is connected to an filament of triode valve. Triode valve has three valves, a cathode, a grid and an anode. So the secondary coil of step down transformer is connected to a filament of triode valve. The secondary coil of step up transformer is connected to the anode circuit. How the anode circuit is connected to the oscillator circuit. So this is connected to the oscillator circuit and back to the filament. So the mission circuit has two transformers, step up transformer and a step down transformer. Both the transformers are connected to AC current. It has two transformers, step up, step down, which is connected to an AC current. The secondary coil of step up transformer is connected to a filament of triode valve. The secondary coil of step up transformer is connected to the anode circuit through the oscillator. The anode circuit is this, which is connected to the oscillator circuit, and then it is back connected to the filament. So close to the CD coil, there is another coil called AB, which is connected to the grid, and through grid resistance it is connected to the filament again. So this is construction. Coming to the working of these circuits in shortwave diathermy. First, from the AC current source, current is passed through step down and step up transformer. So the current in the step down transformer is passed to the secondary coil. It's connected to the filament of triode valve. The filament is heated, then it releases the electron. The electron is then attracted towards the anode. This anode carries this current through the oscillator circuit. Through the oscillator circuit, it is connected back to the secondary coil of step up transformer and back to the filament. This is how the pathway looks. when the current flows from the cathode in this pathway, when current flows from the cathode to the oscillator circuit, current is flowed through CD, this coil CD. This coil induces an EMF in BA, the direction of BA, which is connected to the grid. So it makes the grid positive. When it is positive, what happens? There's no flow of electron, so current is cut here. There's no flow of current. So this drop in the current produces a self-induced EMF in CD. This will cause charging of the condenser XY, and self-induced EMF will cause charging of condenser in X and Y. This is the condenser of condenser in oscillator circuit. So this will be charged. Now then, when this self-induced EMF is dropped, this charged condenser discharges. So the current again flows in this direction, so CD. When current flows to CD, there is an induced EMF in AB direction. So again the grid is made negative, so again current flows. So the same cycle continues, the charging and discharging of the condenser. So this grid, when this current flows, there's some current which is stuck in this grid. So this grid leak is present to carry this current back to the filament. So close, when current is induced in CD, there will be resonating current in EF, which is the patient circuit. When EF has the current, there is current in the which is passed through the patient circuit. This is about the working of shortwave diathermy.